Alright, section 9.2, the quadratic formula. People are probably breathing sighs of relief right now because the quadratic formula makes solving quadratics so easy. So easy indeed. It's the fourth technically, third and final method for solving quadratics. Definitely the third for ax squared plus bx plus c. First way was factoring. Second way was complete the square. The third is now the quadratic formula. You can throw the square root property in there as well, but that's really a part of complete the square. So really this is the third way. Quadratic formula looks like this. It's beautiful, I know, you are loving it. You want to put it as your wallpaper. But let me show you where it came from. Okay, so the first thing we're going to do is we're going to see where the quadratic formula came from. And we're actually just going to complete the square. That's all we're going to do. We're going to complete the square, okay? Same formula. The only thing that's different now is, unlike last time when I didn't show you it with variables, I'm going to show you it with variables now. And you're going to find that we get the exact same thing for the quadratic formula. So, I'm going to start with my standard form. Ax squared plus bx plus c equals 0. Standard form, right? Ax squared plus bx plus c equals 0. Now remember, the first problem we had, the first issue we had with complete the square was when we had 2 in front, right? And that was an issue. And so what did we do? We divided by that 2, we got rid of it. I now have that same issue with this number a, right? Remember, a is just a number. I'm not guaranteed it's equal to 1, so I'm going to get rid of it. I'm going to divide by a. Divide by a, divide by a, divide by a, divide by a. Well, I can reduce a couple things. I know a and a cancel, so I'm just left with x squared. The other two here, I don't know what a is, so I can't exactly cancel them, but I can rewrite them as b over a times x plus c over a. And this last one, 0 divided by anything, is just going to stay as 0. Okay? So I have this new kind of weirder looking formula, but it's not too bad. It's not too bad. Not too bad. Alright. Now I'm going to think back to what I did when I had something like this. So on in the regular complete the square, okay, the first step was, that's right, get rid of the c. Get rid of the thing that was on the end here. Get rid of this constant by moving it to the other side. So I'm going to do that too. Keep the first two exactly the same as they are, as we've done up until now. But I'm going to move the c to the other side. So I get negative whatever the heck I move to the other side, c over a. Right? Move that last term to the other side. Okie dokie. Next, I remember that I had to put in something here. I had to put in something there. It was whatever was sitting next to the x, b over a, divided by 2, right? Now that's a complex fraction, so I can rewrite this as b over 2a. b over 2a. And then what did I have to do to it? That's right, I had to square it. Once I found that number, that 1 or that 6 or that 3/2, I had to square it, and that, pardon me, was what I put in here for the purple slot. b over 2a squared. And that's what I did to the other side as well. b over 2a squared. Alright. And from here, because I have variables, I'm going to take just a little pause to simplify this b part down. So again, I'm going to leave these two guys exactly as they are. Exactly as they are. I'm going to leave the minus ca exactly as it is. And I'm going to simplify this using distribution rules. So I'm going to distribute that. I get plus b squared over 2 squared is 4a squared. So I just made that less parenthesis, more variables. That's all. More squareds, less parentheses, that's all. And I still have this thing. It's getting bigger, but that's okay, right? It's getting bigger, but that's okay. I know where all these pieces came from. Alright, after that, I remember that this left-hand side is supposed to factor into a quantity squared, x, and it's supposed to factor into x plus whatever I got for that b over 2 thing. So plus b over 2a, right? That's what it was supposed to equal. And then on the other side, I just had to add these, right? Now in order to add these guys, I have to make sure their denominators are the same. What's missing from the first one? A 4a. So I think I'll go up here. No, I'll stay right here. I'll do this. I'll just do it in here. So negative c over a times 4a over 4a plus b squared over 4a squared. When I do that, I end up with 4ac on the top, negative 4ac on the top, and 4a squared on the bottom. So let's rewrite everything. This is still the same step, so I'm going to keep it in the same color. Left-hand side not changing, right? Left-hand side not changing. But like I said, I end up with 4ac, negative 4ac, over 2 a's and a 4 is going to be 4a squared plus b squared over 4a squared. Now they have the same denominator, so again, same step, I'm going to write in the same color. X plus b over 2a squared is equal to, and I'm going to put the b squared first just because I don't like negatives in front. B squared minus 4ac all over, 4a squared. Starting to sound familiar. Alright, I will admit that this right-hand side is not very pretty, but if I plugged in a, b, and c, it would just be a number, right? So that's okay, right? It's okay. I know where it came from. I'm good. I can now take the square of both sides, right? Because now I have something being squared, so I can take the square root so that they cancel. I end up with x plus b over 2a. What I do to one side, I got to do to the other. So I end up with that equaling plus or minus square root of b squared minus 4ac all over 4a squared. And just like my regular problems, I'm not going to worry about reducing that until the end. And so then the final step, I will move this b to the 2a over, b over 2a over, pardon me. X equals minus b over 2a plus or minus square root b squared minus 4ac all over 4a squared. Last thing I'm going to do is simplify. I know that 4 is a square and a squared is a square, so I can square root that, right? Use that quotient rule. The top stays in a radical, but the bottom is going to go down to negative b plus or minus b squared minus 4ac. What's the square root of 4a squared? That's going to be 2a. Matches the other one, so all over 2a. And we have our quadratic formula. X is equal to minus b plus or minus the square root, b squared minus 4ac, all over 2a. And that is our beautiful quadratic formula. Cool, so that's how it works. That's where it came from. Somebody just completed the square with variables. That's all they did. So really, complete the square is much more powerful than the quadratic formula. If you're having trouble remembering it, you can just sing Pop Goes the Weasel. Pop goes the weasel. That's one way I've heard it being remembered. Goes x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Pop goes the weasel. Okay, cool. Now that we have this formula, let's go ahead and use it to solve some of these guys. Let's use it to solve these. So remember, in the formula, it doesn't matter if a is equal to 1 because we've got an a in our formula. So our formula is x is equal, well, first let's identify a, b, and c. A is equal to 2, b is equal to 9, c is also equal to 9. Let's plug in. X is equal to minus b, so minus 9, plus or minus square root of b, which is 9, squared, minus 4 times a, which is 2, c, which is 9, all over 2 times a, which is 2. So notice I just plugged in the values, right? I knew what a, b, and c were, so I plugged them in. Now let's simplify. We've got, let's see, negative 9 plus or minus square root. 9 squared is 81, minus 4 times 2 is 8, times 2 is 70, times 9 is 72, all over 2 times 2 is 4. Keep going. I'll take care of that minus under the radical. Negative 9 plus or minus the square root. I want to say 9. Yep, 9 over 4. Lucky for us, 9 is a perfect square, so that'll square root to x equals negative 9 plus or minus 3 over 4. And remember, I have two equations here. Negative 9 plus 3 over 4 and negative 9 minus 3 over 4. So at this step, I cannot simplify them together. I must actually split into two separate equations. So I have negative 9 plus 3 over 4, which would be negative 6 over 4, which would be negative 3 halves, and negative 9 minus 3 over 4, which would be negative 12 over 4, or negative 3. So my two answers end up being x equals negative 3 over 2, comma, negative 3. And that is how, that is how one uses the quadratic formula. Alrighty, let's try it again. So I have x, well, let's identify a, b, and c. A is equal to 6, b is equal to negative 5, whoops, not 15. And c is equal to negative 4. C is equal to negative 4. So I'll say that x is equal to minus b minus a negative 5 plus or minus the square root of b, which is negative 5, squared minus 4 times a times c all over 2 times a, which is 6. So yes, even if the b is negative, you still have to negate it. You have to do it twice, okay? So this is going to bounce back to a positive 5. 5 plus or minus the square root. 5 squared, negative 5 squared is a positive 25. Positive 25. Minus, let's see, 4 times 6 is 24. 24 times 4 is 96. So I've got a negative times a negative becomes a positive, so plus 96 over 12. That would be 96 plus 25 is 121, so we got 5 plus or minus square root 121 over 12. Again, lucky for us, 121 is a perfect square, so we have 5 plus or minus 11 over 12. And once again, from here I cannot reduce. I cannot simplify until I split them up. So I have 5 plus 11 over 12 is equal to 16 over 12. That's, I can reduce by 4 to get 4/3. And then I also have 5 minus 11 over 12, which would be negative 6 over 12, or negative 1/2. And so my two answers, x equals 4/3, comma, negative 1/2. You can use brackets, or circle, or box, or whatever you want. But okay, so hopefully this formula is starting to make sense as you break it down. But let's go ahead and do another one. And then we'll go talk about some weird ones, things that don't work. So a here is equal to 2. B is equal to 9. C is equal to negative 4. I know x is equal to minus b, so minus 9, plus or minus the square root of b squared, 9 squared, minus 4 times 2 times negative 4. If you drop those negatives, that could be a problem, so watch out for that. All over 2 times 2. Simplify away. Got negative 9 plus or minus square root of 81 minus 4 times 2 is 8 times 2 is 32, so we'll add a 32 because one of them is negative, so it ends up bouncing back over 4. 81 plus 32 is 113. So negative 9 plus or minus square root of 113 over 4. And unfortunately, this time it is not a perfect square, right? It's not a perfect square. So, and even more, it's actually prime, so we can't factor it down. And so this is actually our final two answers. We can rewrite our final answer as x equals negative 9 plus or minus square root of 113 over 4. That would be our final two answers. Remember, two answers because it's plus and minus. Alrighty. Let's talk about this one. This one's a little strange. Let's not use orange. I'm bored of orange. Let's not use green. Let's use red. I have 4x squared is equal to 8x minus 1. Well, this isn't in our classic standard form. That's the problem. So how I'm going to fix this is I'm going to move the 2 over. By all means, you're more than welcome to move things to the other side. Right? You're welcome to move things to the right-hand side. It works the same, right? Equalities can be written forward and backwards. I like positive exponents though. Positive a's. For some reason, I just like positive a's. So I'm going to move things over to the left-hand side. So I end up with 4x squared minus 8x plus 1 is equal to 0. If you went the other way, you'd end up getting negative 4x squared plus 8x minus 1 is equal to 0. But the negatives will cancel each other out in the quadratic formula. All right, a is equal to 4. B is equal to negative 8, and C is equal to positive 1. Alright, I'll stick thread. X is equal to minus negative 8 plus or minus the square root of B squared, so negative 8 squared, minus 4 times 1, all over 2 times 4. And there's the real reason right there, because I don't want a negative in the bottom. So if I had moved the a to the other side, I would have had a negative in the denominator. Really doesn't change much. Remember, negatives in the denominator, just you can pull them out. But that's a lot of double negatives, and I just don't feel like dealing with it. So, okay, cool. Let's simplify. I get negative 8 becomes a positive 8, plus or minus. Negative 8 squared is going to be a positive 64, minus 4 times 4 is 16, times 1 is still 16. All of that over 8. 64 minus 16 is 48. So I have 8 plus or minus square root of 48 over 8. Now, 48 is not a perfect square, but it is reducible, so I can do that over here in like a little mini section here. 48 goes into 8 and 6. That's 2 and 2 and 2. And that's 2 and 3. So I've got 2 pairs of 2's. Looks like it's 4 root 8. So I've got 8 plus or minus 4 root 3 over 8. So 4 root 3, right? Because I have 2 and 2 makes 4 on the outside. There's 1 3 left over on the inside. And I can't simplify it down to a whole number, but I see some things in common, right? I see that this 8 and this 8, and then I also have a 4. So if I were to split this into 2 fractions, 8 over 8 plus 4 thirds over 8, right? I would get 1 plus or minus 1 that would go down to 2, so root 3 over 2. If I wanted to keep it as one fraction, though, I could just split them up by the 8, right? So I'd end up with 2 plus 2 root 3 over 4. That would 2 plus root 3 over 4. That would cancel. So the 4 would reduce that down to a 4. That would reduce that down to a 2. Yeah, divide everything by 4. Over 2. Sorry, no, over 4. Let's just go with this one. This one's fine. Let's just go with this one. And that's my final answer. Okie dokie. Cool. So if you have things in a weird order, feel free to rearrange them so that the quadratic formula will work. Next up, we have a very weird order. We have a factored form that's equal to negative 4, and that's a problem. If it was already a factored 4 equal to 0, then we could just use zero product property, we can move on with our lives, but it's not. So we have to multiply it out to start with. So I get 9x squared minus 9x plus 3x minus 3 equals negative 4. Combine like terms, you get 9x squared minus 6x minus 3 equals -4. And the only reason I had to do that is because now I have to put the 4 into the property, right? So the 4 was the problem. Wasn't the fact that it was factored form. Factored form would have been extremely helpful. We could just solve that from there. But the -4 is still part of this equation, so it's got to be lumped back in. I can't use any of this until it equals 0, right? So I end up with 9x squared minus 6x, see, plus 4 to the other side, plus 1 equals 0. Now I can use my quadratic equation. Let's not do red though. Let's do orange. X is equal to minus b, so minus -6, plus or minus square root of b squared minus 4ac all over 2a. Right? That's how that works. So I plugged in all the numbers. I didn't separate them out this time because I feel like we can kind of see where that's coming from. If not, then make sure you email me and I can help you out. Okay, so -6 becomes a +6. -6 squared is still going to be a +36. Always a positive, no matter what, right? Minus 4 times 9 times 1 is 36 over 2 times 9 is 18. Okay, keep simplifying. We get x is equal to 6 plus or minus the square root of 0 over 18. Interesting. Remember what we said about 0 in the last video? It's the only square root that only has one answer. So this actually just simplifies to plus 0, plus or minus 0 over 18. When you plus or minus 0, you end up with the same thing. We end up with 6 over 18. Or in other words, divide both by 6, 1 over 3. So 1/3 is our only answer in this case. It's the only number that actually works. Because we got a square root of 0. Okay, 2 more. And then we'll talk about the discriminant. 2 more. Okie doke. So I've got this one's set up in a perfect order. Good. Sweet. Let's see what happens if we use the quadratic formula. So x is equal to minus b plus or minus the square root of b, -3, squared minus 4a is 4, c is 2, all over 2 times a is 4. Yep. Simplify, we get -3 becomes a +3, plus or minus. Square root of -3 squared is 9, minus, let's see, 4 times 4 is 16, times 2 is 32, all over 8. Simplify a little bit, we get 3 plus or minus the square root. Let's see, 9 minus 32, interesting, -23 over 8, whoops. And now we can see a problem, right? We can see that we no longer have a real number. We no longer have a real number. That happens too. That's okay. Because we know how to deal with complex numbers, right? So we have 3 plus or minus the square root of -23. Oops, not -23. We're going to take out the negative part, so we'll call it I root 23 over 8. Since 23 is a prime, we can't reduce it. 3 and 8 don't reduce, so the only thing we can do to reduce is take out that I, and that's our answer. And that's okay, right? It's okay. We have cases where we have 2 answers, we have cases where we have 1 answer, we now have a case where we have imaginary answers, 2 imaginary answers, right, technically. So, it happens. It happens sometimes. It really depends on how this happens underneath this radical. Let's do one more, though, see what happens in this last one. So now we've got plus, no, what am I doing? Sorry, I'm trying to complete the square. So you can see complete the square is my favorite. X is equal to minus b plus or minus square root of 3 squared minus, let's not put parentheses there. So 3 squared minus 4 times, let's see, a is 1, c is -28, all over 2 times 1 equal to minus 3 plus or minus square root of 3 squared is 9. 4 times 28 is 112. So minus 112 over 2. 9 minus 112. Wait, hold on. My apologies. Negative and a negative make positive. So that would be 9 plus 112. I don't know why I'm doing that on a calculator. Is 121. Negative 3 plus or minus square root of 121 over 2. Yay, lucky for us, that's a perfect square. And it's real, right? That's real perfect square. So this simplifies to negative 3 plus or minus 11 over 2. And then we can make two equations. Negative 3 plus 11 over 2. That ends up being 8 over 2. Oops. 8 over 2, which is equal to 4. And then we also have negative 3 minus 11 over 2, which would be negative 14 over 2 or negative 7. So our answers, x equals 4 or negative 7. We don't even have to leave it in plus or minus because of that perfect square. So we've got things that simplify to nice, easy whole numbers. We've got things that aren't even real, two numbers that aren't even real. We've got one number. We've got numbers that are real, but what we call irrational, right? Irrational because they've got those square roots in them. So yeah, irrational, it's not a term we'd used so far this year, but now we're going to. And those are our basic 4 types of answers that you can get. So these last 4 problems kind of give you the whole spectrum.